Good morning, everyone. Today, I will give you the last lecture, reliability analysis. Reliability analysis, we have several different reliability coefficients. One of the most commonly used is Cronbacher's LPAR. In this class, we will discuss Cronbacher's LPAR. So briefly, we can call it LPAR. Okay, now let's look at the case. Here, a set of evaluation scale was designed to test psychology of college students. Evaluation items include X1, dominance, X2, stability, X3, sociality, X4, excitement, X5, activity, and X6, thoughtfulness. So totally we have 6 items to evaluate. Each assessment is divided into 20. The higher the score, the better the psychological quality. Okay, now we want to study the credibility of the evaluation system. We want to know if the evaluation items are appropriate to test or to assess the psychological quality of the students. Okay, if you conducted the research from questionnaire, also it's very important to test the reliability of the questionnaire. Now, 44 students were pre-tested. Please analyze the internal consistency of this scale using reliability analysis method. Here is the operation steps, and I can see that you have done. You can complete step by step. Okay. Here we have 6 items. And the measure of the items are scale. Okay. Because here we can select the measure. Include scale, ordinal, nominal, and right now they are all scale. And here X1 to X6, we have 6 items and 44 respondents. Okay. Firstly, we select analyze. Okay, and here scale. Scale, the first one is reliability analysis. Selected. Okay, please add the items, the 6 items into the items box and check the model. Select LPAR. In fact, the default model is LPAR. Okay, and then click statistics. Here, descriptives for. Please select scale. Scale if items delete. In an item, please select correlations. Okay, so for this reliability analysis statistics, 1, 2, 3. Then continue. Okay. Now, you get the output of the reliability analysis. From here, first let's look at the reliability statistics. For the LPAR, okay, here is the LPAR. The value is 0.835. 0.835. In fact, Cronbach's LPAR is from 0 to 1. Higher the value, more reliable the scale. Okay, so now the LPAR is 0.835, which is more than 0.8. It indicates that the internal consistency of this assessment system is ideal. Okay, so it's very appropriate. It's ideal. Okay, so from here you can have this conclusion. Okay, then next, please look at this table. Okay, here is item total statistics. Okay, from here you can see that the squared multiple correlation in this column, dominance 0.665, stability 0.451, sociality 0.706, activity 0.568, and thoughtfulness as 0.572. Okay, only the excitement, the squared multiple correlation is 0.288, which is less than 0.3. So this excitement is lowest. So that means excitement has low correlation with either items. Okay, I will demo how to calculate, how can you get the result 0.288. Okay, most important, let's look at the LPAR. If item deleted, it means, for example, if we delete dominance, we remove dominance from this scale, then the LPAR will be 0.823, which is lower than 0.835. It means dominance. Dominance can be kept. It will be better for dominance to kept in the scale, because when we delete dominance, the LPAR will decrease. Also, if we delete stability, then the LPAR will decrease to 0.825. Decrease. So that means all of these 5 items can be kept in the scale. Only this item, excitement. If we remove excitement from the scale, then the LPAR will slightly increase to 0.837. Okay, so it means the item excitement should be adjusted or deleted. Okay, yes. Okay, so that's the analysis of this reliability. Okay, now I would like to demo how can you get all of these values. Let's look at the first value. Scare mean if item deleted. Yeah, please note this value. 74.7159. Scale variance if item deleted. 211.586. Okay, are you demo? How can you get these two value? Firstly, let's calculate for each sample. Okay, for each sample, let's calculate the total value of these 6 items. For example, I would like to establish a y0. Okay, so y0 means the sum of 6 items. And then next is y1. y1 means dominance is deleted. Okay, if the dominance is deleted, if x1 is deleted, the sum okay, so that means the sum exclude x1. y0 transform compute variable. Okay, so y0 equal to x1 add x2 add x3 add x4 add x5 add x6. Okay. Okay, now y0 is the sum of x1, x2, x3, x4, x5, x6. Okay, here is y0. And then y1. y1 is the sum of the items exclude x1, right? So transform compute variable. Here we will use the sum y0 minus, because x1 is deleted, so minus x1. Okay. Okay. Continually. Okay, here, yes, measure nominal. Yeah, I would like to change it to scale. Okay, it's not the nominal. Okay, so also if you want to calculate at y2, which means the sum exclude x2, right? Okay, then we can transform. Oh, sorry. Yeah, I do something wrong. Sorry, I repeat it. Okay. Why? Because I didn't change the y0 to y1. So I need to recalculate y0 and y1, y2. Sorry. Okay. x1, add x2, add x3, add x4, add x5, add x6, that's y0, and then calculate y1, sorry, here it should be y1, and then here is the y0 minus x1, okay. Okay, next is y2. The sum excludes x2. So sum of 6 items minus x2 stability. Okay, here is y2. Okay, now here, y2, transfer the measure from nominal to scale. Okay, so now we have y1, y2, right? Okay, so that's the sum exclude x1, sum exclude x2. Okay, then analyze. So with the same method, you can get y3, y4, y5, y8, y6, right? Here I don't do all the remainder. You can do it after class. Then analyze descriptives, right? And add the sum exclude x1, the sum exclude x2. Options. Here, we want to select the mean and the variance. The mean and the variance, okay? Yeah, continue. Okay, now you can see that sum exclude x1. The mean is 74.7159 and the variance is 211.586. Okay, you can compare them. And here is what you have done, right? Yeah, look at the item total statistics. Now, we have done these two of them. Okay, look, 74.7159. Yes, from here you can see also it's 74.7159. Okay, 75.5795. Okay, so here this value, the values in item total statistics, the first row, the first column, the second column is calculated by the method right now I demonstrate. Okay, got it. Okay, next I will demo the collected item total calculation. Here the dominance is 0.752. Stability 0.584, right? Okay, 0.752, 0.584. That means 0.752 is the correlation between the dominance and the square mean if item deleted. This one. Okay. No, sorry. The calculated item total is the X1 and the Y1. Y1 and X1. Okay. So here is dominance. And the sum exclude X1. We will analyze the correlation between the X1 and the sum exclude X1. And then next is the X2, the correlation of X2 and Y2. So that means it's the stability, and the sum exclude the stability. Let's look at the correlate. Here we will use the Pearson, okay? And firstly, X1 is X1, and Y1, the sum exclude X1. Okay, now look. Now we can get the dominance, and the sum exclude dominance. The Pearson correlation is 0.752. Okay, 0.752. Okay, also here, look, the correlated item with total correlation is 0.752. Okay, so also you can practice the stability and the sum exclude stability. Here is 0.584, right? Okay, so you can repeat. Stability. Sum exclude X2. Look, here is 0.584. Okay, so you can see that how the values calculated. Okay, so higher the value, higher the correlation, it means this item and other items has very close relationship. So that means they can be used in the same scale. Next, let's look at another. Look, the fourth column is squared multiple correlation, right? Squared multiple correlation. The dominance is 0.665. Stability is 0.451. Yes, I record them. Okay. So, squared multiple correlation for the dominance is the dominance will be the dependent variable, y. The remainder items, stability, sociality, excitement, activity, assertiveness, all of the remaining items will be the independent variable, which is x. Okay, so here, firstly, regression, linear. Okay, so here, the dependent is dominance, right? And the independent is x2, x3, 4, 5, 6, the remaining items. So that means all the items excluding dominance. Okay, the method is enter. Then, okay. Now, look, you have the output of the linear regression. And here you can see the model summary. The R is 0.815. R square is 0.665. 0.665 is the fourth column. Okay. So you can record 0.665. Okay, so here 0.665 and here 0.665 squared multiple calculation. That's this value. Where is this value from? Okay, next I will repeat the stability. The squared multiple correlation of stability. It means stability will be the dependent variable and other items will be independent variable. To establish a linear regression, and in the linear regression you will have the squared analyze regression linear. Now here dependent variable is stability. I remove the stability from independent to dependent and then add dominance into the independent. Okay, so now we have x1, x3, 4, 5, 6 in the independent box. Method enter. Dependent x2 stability. Okay, now also here you can see the model. The R square of the regression model is 0.451. Okay, 451, which is 451. That's the same. Okay? Okay. Lastly is the Cronbach's LPAR. If item deleted, first is 0.823. Second, 0.825. Yeah, let's do the dominance first. If dominance is deleted, then what the LPAR will be? Analyze, scale, reliability analysis. Okay, so firstly, we remove x1 dominance. We leave other items. And then, okay, yeah, we will keep all of them, right? 1, 2, 3. And now, we only use this output. Look, when x1 is excluded, then the error part will be 0.823, which is less than 0.35. Okay, so it's 0.823. Okay, how about the X2 is deleted? Also, analyze, scale, reliability analysis. Now, X2 will be removed and X1 will be included. Okay, so that means we remove X2, we leave other items. Okay, now you can see that when we remove X2, then the error part will be 0.825. It means when we delete the X2, the error part will decrease. So it means X2, it will be better. We keep the X2 in the scale. Okay, hope you can understand what I'm talking. Okay, so here, for the analysis, okay, so you need to use this analysis and this analysis, okay, to answer the questions. Okay, that's the reliability analysis. Thank you for listening.